a little bit of new material. Okay. All right. If I can get this to where you can see it a little bit better. Let me see. Adjust accordingly. So it says Rachel and her friend Sarah commit to become avid walkers. They decided to get a regular walking program. They are to walk a distance of 2 kilometers the first week. So they're going to do 2 kilometers the first week, 6 kilometers the second week, 18 kilometers the third week, and so on. So put dot, 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 meaning so on. Their goal is to walk 150 kilometers during the 5th week. So the 5th week, they want to walk 150. Write the explicit formula for the sequence. The reason why I was writing this as I was reading, because this is your sequence. First week is 2. Second week, 6. Third week, 18, so forth, so on. So to write the explicit formula, I want to use this. A sub n equals a sub 1 times r to the n minus 1. So my first term I know is 2. That's the first term in the sequence. Now I got to look at my common ratio. What did I multiply? Or you can divide. Say 18 divided by 6 gives me 3. And then 6 divided by 2 gives me 3. That is the common ratio. That is what is being multiplied by each number to get the next number. Okay? So here, the first term is 2 times 3 to the n minus 1. So that a sub n equals that. So that is the explicit formula. Will Rachel and Sarah meet their goal? So it says their goal is to walk 150 kilometers during the 5th week. So we need to determine how far would she have walked the 5th week. So continuing at this rate, we're going to say a sub 5, we want to find the 5th week. So you have 2 times 3, 5 minus 1, which is the same thing as 2 times 3 to the 4th power. Now, when I go to place that in the calculator, I'm going to get 162. Okay? So she would have walked 162 kilometers. What was her goal? 150? Oh, yeah. They walked over. Okay? Did they meet their goal? Yes. They actually exceeded their goal. Yes. They will, if they continue at this rate, they will exceed their goal. Yep, they will exceed their goal if they continue at this rate. Is there any questions about geometric sequencing? All right, so let's keep moving. We're going to keep moving. So now let's talk a little bit about compound interest. And then we are done for today. So we're going to write a few notes. What is compound interest? Okay, so if I can get this here. The compound interest is the interest paid on both the principal which is the initial amount, and I'm going over my thing, which is the initial amount, and the interest earned so far on the principal. And I'm sorry, my handwriting is a little sloppy, but it's the interest paid on both the principal, which is the initial amount, and the interest earned so far on the principal. That's FAR. I'm going to rewrite that. All right. So this is the compound interest formula. And so you need to know this. A equals P times 1 plus R over N to the NT. That's how I remember it, because it kind of rhymes. R over N to the NT. A equals P times 1 plus R over N to the NT. Okay. So the P is the principal or initial amount. Initial amount. The N is the number of times compounded per year. So it's going to be like compounded quarterly, so forth, so on. So it'll be the number of times compounded per year. The R is the annual rate expressed as a decimal. So it's the annual rate. And of course, if it's a rate, it's percent, but it's expressed as a decimal. Expressed as a decimal. Your T, of course, is the time in years. And the A is the amount after, it's the final value, amount after T years. Which is the final value. Which is that final value, amount after T years, which is the final value. So basically, we're going to use this formula to solve the following problems, okay? Within each problem or word problem, you have to pick out the important pieces of information that you're going to need in order to solve it. So we're going to pick out the important information within each problem, okay? So it says find the value after 2 years of an investment of 1,250 compounded annually, okay? Compounded annually at an annual rate of 8%, okay? Compounded annually. If it's compounded annually, that's once a year, okay? So first what I'm going to do is write the formula. A equals P times 1 plus R over N to the NT. Then if you look on the side, I want to plug in the information, okay? Find the value after 2 years. What is 2 years? That is the what? What would 2 years be? Can somebody tell me? 2 years is the amount of time. 2 years would be the amount of time. It said after 2 years, that is the amount of time, okay? So find a value after 2 years, and I'm going to highlight a few things. And for T, I'm going to put 2. Of an investment of 1,250. So an investment of, this is what they invested, that amount. So keep in mind, the P is the initial amount. The A is that final amount. So the amount they invested, that initial amount would be 1,250. Compounded annually. Remember, if it says annually, that's once a year. And the N stands for the number of times compounded per year. So that'll be 1. And the rate is 8%. The percent is always going to be your rate. And so when you're dealing with that, you're going to change 8% into a decimal. Move it 2 places to the left, which equals 0.08. And that's what we want to put in, the 0.08. So now I'm just going to place it into my formula because I want to find my A. This is what I'm solving for, the final amount. So we're going to say A is equal to, the P is 1,250 times 1 plus, the R is 0.08, all over the N, which is 1, to the NT. So it'll be 1 times the 2. So all I did was take this information, plug it into that formula. And when I did that, if you notice, when you calculate, you're going to put it in a calculator like this. This is what I'm going to recommend. First of all, I would do this piece first, the fraction inside. Anything divided by 1 is itself. So you have 1250 times 1 plus 0.08. And I'm going to multiply 1 times 2, which is just 2. So we're simplifying this. Then go ahead and add this together. 1250. 1 plus 0.08 is 1.08 to the second. Now I would put it in the calculator. I just don't want you putting it into the calculator like this and putting it in wrong. So from there, you're going to say 1250, open parentheses, 1.08, close parentheses, to the power of 2. And it's going to give you $1,458. That is the answer, okay? And the more you do them, the easier they will become. So now let's look at number 2. Again, we're using this formula, so I'm going to write the formula that I'm using first. A equals P times 1 plus R over N to the NT. And then I want to pick out my key things. It says find the value after 2 years. 2 years. So we know that that 2 years should be the amount of time of an investment of 1,250. So basically it's the same thing, 2 years of that investment, but this time instead of compounded annually, it's compounded semi-annually. Semi meaning twice a year here at an annual rate of, again, 8%. So everything else the same, but instead of compounding it annually, we're compounding it semi-annually twice a year. So you have your 2 years, that's your time. You're investing $1,250, that's the principal amount. The number of times compounded is now going to change, that's going to be 2. And your rate is still 0.08 or 8%. And we want to know what would be the final amount. Okay. So if you look, we're going to do A equals, the principal is 1,250 times 1 plus, the rate is 0.08 all over the N, which is 2, to the NT. So it would be 2 times 2. So again, start inside here first and calculate. You want to do 0.08 divided by 2. So I'm going to put that in the calculator. 0.08 divided by 2 gives me 0.04. So I have 1250 times 1 plus 0.04 because I simplified that first. Then 2 times 2 I know is 4. Go ahead and add this together. 1 plus 0.04 would give me 1.04 to the 4th power. And now I want to take all of this and place that in the calculator. And when I do that, I'm going to get $1,462.32. When you're dealing with money, you always round to nearest hundredth. And here we're dealing with money, so we want every cent. We want it all the way up to that penny. Okay? Let's look at the next one. Again, guess what I'm going to write first? I'm going to write the formula because this is the formula I'm dealing with. And it says Susie invested. When you invest something, that's the initial amount you're putting into something. So invested $1,000 in a certificate of deposit or a CD that earns 5.5 interest, compounded quarterly. How many quarters are in a dollar? 4. So quarterly would be 4 times. It's compounded 4 times a year. For 10 years. For 10 years. Okay. How much will the CD be worth at the end? Okay. How much will it be worth at the end? Okay. So if you look here, we're going to plug in the important information. She invested. That was the initial amount, which is the principal, $1,000. that earns 5.5% interest. So if it's 5.5%, we want to change that into a decimal. We move it over 2 places to the left, and that's going to equal 0.055. Compounded quarterly, again, the N is the number of times it's compounded, so that would be 4. For 10 years, that's my time. So we want to find this, the final amount. Again, all I'm going to do is plug everything into the formula. 1,000 times 1 plus the rate of 0.055 all over the N, 4, to the NT. So it's 4 times 10. Okay. So when you do that, you're actually going to do this piece first. Remember, we divide first here. So you're going to have 0.055 divided by 4. That's going to give me 1,000 times 1 plus 0.01375. 4 times 10 to the 40th power. Then add this together. You're going to get 1,000 times 1.01375 to the 40th. And now it makes it easier to put in the calculator. 1,000 times 1.01375 caret key 40. And you get $1,726.77. Again, rounding to the nearest hundredth because we're talking about money. Okay? And that's the final amount. Let's look at number 4. We're almost finished. Okay? So here for number 4, it says find the amount of compound interest at the end of 5 years if $2,000 is invested at 10% compounded monthly. Okay, so I'm going to again write my formula. So find the amount of compound interest. So we're using the amount compound interest at the end of 5 years if $2,000 is invested. So we're investing $2,000 at the end of 5 years, 10% compounded monthly. How many months are in a year? We know there is 12 months in a year, so that's the number we're going to place in. So 5 years would be the amount of time. The 2,000 in which we invest would be the principal amount. 10%, we would change that 10% into a decimal, which gives me 0.10. And compounded monthly would give me 12 here for my N. So now we'll just plug it into my formula. A equals 2,000 times 1 plus the rate of 0.10 all over N, which is 12, to the N times the time, which is 5. Again, do this part in the inside. 0.10 divided by 12. That's going to give you A equals, and we're going to have to round a little bit here, 1 plus 0.0083, and then it began to repeat. 12 times 5 is 60. So you have A equals 2,000 times 1. When you add those two together, you get 1.0083 to the 60, and that's what I'm going to put in the calculator. And I get, oh, did I do that right? NT. Make sure I did everything right. Yep, and I get $3,284 and I'm going to say 10 cents. I'm going to round it up. Now, on your key, it has something a little bit different. So you want to make sure, and that's why I'm checking over myself, you change that, because on the key it's something a little bit different. So this is correct what we did here. Let me make sure our negative 10 about 12.0083. We added that together, and then 12 times 5 gave me 60. Okay, and that's correct. All right, again, on your key, it's a little something different. It says find the amount of compound interest at the end of 5 years. Oh, you want to find the amount of compound interest. That's why it's a little bit different. All right, so here we go. If this is the amount that you have after 5 years, what you're going to do now is you're going to subtract the 2,000 from it. Because if you look, the compound interest would be this minus the 2,000, which would give you 1284.10 approximately. Okay, and it really depends on how you round it. So let me go back to this one more time. If you look, this is the amount that you get after 5 years. That's your amount. But they actually define the amount of compounded interest. So if this is the amount after 5 years, then what you're going to do is take this amount, subtract it from your initial amount, and this is how much you had of compound interest. $1,284.10. And again, it depends on how you round it. It depends on how you round it here. Okay? All right? Depends on how you round it right here. All right. So let's go to our last problem, and then the next piece is your homework. So it says Kelly and Catherine both decided to start saving money for a trip to Disney World. Kelly chooses to invest $1,500. So Kelly invests here. She chose to invest $1,500. So that's the initial amount. I'm going to put that here. At 9%, that's the rate, which equals 0.09. Compounded annually, which is one time. Catherine decided to invest $1,500. So Catherine here, if you look at B, her initial amount is also $1,500 at 9% again. So the rate is still 0.09. Compounded daily, so it's a little bit different. There's 365 days in a year, so that'll be number of times compounded, 365. Okay. So here it actually defines the value of Kelly's investment after 2 years here, and then how much Catherine invested after 2 years. So basically finding this after 2 and this after 2. So we're going to use the formula A equals P times 1 plus R over N to the NT. A equals P times 1 plus R over N to the NT. So if you look here, the principal amount is $1,500 times 1 plus, the rate is 0.09 over N, which is 1, to the NT, which would be 1 times the 2. Now I'm going to go ahead, for the sake of time, give you the answer to this one. This one would be $1,782.15. And this one here, when you plug in 1,500 times 1 plus R, 0.09 over N, 365 to the NT. So that'll be 365 times 2. Then you're going to get $1,795.79. So after 2 years, whose account is greater? Is there a significant difference? Catherine's account, again, is greater. Is greater. And Catherine has $13.64 more. Okay, so this is not a significant difference. Okay, she only has $13.64, which is not a significant difference, Now, this is your homework. You're going to complete that homework, and then you're going to come back on our next section ask me any questions that you have with this. So please, please make sure you do your practice.